Now, for those of you that are following along in your booklets at home, I've just jumped over. I was starting on page 19 with factoring trinomials where a is not equal to 1, and I've jumped over to page 23 where we're factoring trinomials using decomposition. Now, we've learned decomposition when it came to trinomials where a is equal to 1, but we're going to look one step further and we're going to kind of go through the process again, but now where our a value, and I'm sorry for the variable being a, but that number right there is not 1. And so we're going to look at how does that change things a little bit here as well. So now first things first, okay, we need to go and multiply our a and our c value together. And so that is our first term and our last term. And make sure it's in order, either in descending order, so a squared, a nothing, or in ascending order, so nothing, a, and a squared. So we can switch it around, but make sure it is in that order where the a value, or this x value, okay, remember that's the x value, is there. So this is, remember, a x squared plus bx plus c. So if you remember that, it's right here as well. Okay, so we're looking for a, so we're, again, remember that our variables can change. We're going to say our basic one is x, but we can use a's as well, and we can use any other letter as well. So what we're going to do here is we're going to take our a and our c value, 2 times 12, and we're going to multiply that together, and we get 24. Okay, 24 is our value of that. Okay, it's multiplying those two together. And we want to then find factors of 24. Okay, 1 times 24, 2 times 12, and now whatever we multiply here is always going to be a pair of factors as well. 3 times 8, 4 times 6, and then we have all the negatives as well. Now you don't have to do the negatives if you don't want to. That's negative 12, negative 3 times negative 8, negative 4 times negative 6. You also don't have to do all of them. If you see the one that works right away, you can use that automatically. You don't have to do all of them. If you see the one that works, use that one as it may be a little bit quicker. Now, we're looking for which pair of these adds up to our b value. Okay, so we're looking for what pair of them adds up to b. So it adds up to the 11, and that is positive 3 and positive 8. Okay, so this is going to add up to the 11, which is our middle term there, and so we have to find that pair. Remember, now we're, in this case, the second part we're adding. So we start with the multiplying, the factors, and then we add to figure out which ones are going to add up there. All right, decomposition. So the decomposition part is splitting apart our middle term into two separate terms. So 11 is the same as 3 plus 8. So we haven't changed anything. All we're doing is we're splitting apart that middle term to make it possible to factor. So that's one thing to watch for. Make sure that we do that. These two numbers should still add up to our 11 right there. All right, once we have that, then we need to take a greatest common factor out of each of these here. So 2a squared and 3a, we can take, so we look at the 2 and the 3. There's nothing other than 1 that goes into both 2 and 3. So we're going to take out a 1a because they both have at least 1a. And so this is going to be 2a plus 3. So we divide 2a squared divided by a is 2a, and 3a divided by a is just 3. Then we do the same thing here for these two. We have 8a and 12. There's only the 1a, so we're not going to be taking out an a in this case. But the 8 and the 12, we can both divide them by 4. Positive 4. So this is 2a plus 3. Now we're also looking for something so that we get the same value inside of each of those sets of brackets. Remember, that is one of our binomials. And the other one comes from these two right there, a plus 4. Okay, so you'll notice that when we come up with binomials, one of the a values will have a number in front of it. They might both, and we'll get to maybe some cases where they both have a value in front of it. But in this case, one does, one doesn't. And it's because these two a values have to multiply together to get 2. And these two have to multiply together to get 12. And then again, a combination is going to make 11. Okay, and that's a combination that we're gonna go through there. Now, before we quit this, I want to reverse step 4. Okay, step 4 was putting the 3 and 8 in there. And we went through this in the previous lesson, and I want to go through it again just to kind of show you. 2a squared. So instead of putting the 3 and then 8, I'm going to do the 8 and then the 3. Just to show you that it doesn't actually change our answer, but it's just a little bit of a different way of writing it out, which is fine, okay? Because we're not always going to do things in exactly the same order. Sometimes there's easier ways of writing it out, but for the time being, everything is just the same here. So 2a squared and 8a, we can take a 2 out of these two. So we can take a 2 out of 2 and a 2 out of 8. So we're going to get 2, and we can take an a out of here and an a out of there. So we're going to take out a 2a. Meaning that 2a squared divided by 2a is just a, and 8 divided by 2 is 4, and a divided by a cancels out, so we're left with a plus 4. In this case here, we can't take an a out in this case, but we can take a 3 out of each. We can divide them both by 3, so we're going to take out a positive 3, and so this is a plus 4. Now, again, these are the same, so that's important. A plus 4, and make sure you're showing how you're doing this here, and make sure that the values you're showing are there. And then our other one is going to be these two, so that's 2a plus 3. Now you'll notice these two are exactly the same as these two, except in the opposite order. But remember, when we multiply things together, order doesn't matter, okay, as long as the values are the same. Right? 6 times 4 is 24, just like 4 times 6 is 24. They're the same two numbers. They come up with the same answer. The same two binomials are going to come up with the same trinomial, okay, in the end. And so we can kind of use that as a pattern to follow.